Hello, and a really big warm welcome to this presentation from the Urban Penguin. Continuing with our series, looking at the Python Certified Entry-Level Programmer, we're now going to investigate one of the things that we can do with number formatting. So changing from decimal to binary, binary to hex, and so forth. But also from a practical perspective, for those people involved in networking or system administration, we're going to be looking at how we can convert a dotted decimal IP address through to a binary IP address. And I'm betting you just can't wait for that.
So first of all, what exactly are number formats? Well, so far we've been working with base 10 or decimal numbers, giving us possible values of 0 through to 9, before we then switch units and start working with our tens. Now, of course, this is our default, so there's not a lot that we have to do with it. But we have other number formats, including binary, and this is base 2, and we work with the values 0 through to 1. They're the only possible values that we have. We have a 0 or a 1. When we look at a value 2, well then that's moved that across, so we get a 1, 0. It's a bit like when we have our decimal 10. We've run out of 0 through to 9, so we become 1, 0. 1, 0, though, in base 2 is a decimal 2. If we look at converting, we have a function called bin. This is our binary conversion, and we can convert then an integer, in this case 192, to binary. The output is going to look like this. So starting 0b to show that we're working with a binary. As we look at octal numbers, this is base 8. And that gives us values of 0 through to 7. If we wanted to convert that same decimal number 192 to octal, we would use the function oct and 192, and the output would be 0, lowercase o, and 300 in this case. And finally, we have hexadecimal numbers. This is working with base 16, and this gives us values of 0 through to f. When we get to 9, we're running out of numbers. So 10 would be A, 11 would be B, 12 would be C, 13 would be D, 14 would be E, and 15, our maximum value, becomes F. If we converted that same number in decimal 192 to hex, we would get a value of 0, lowercase x for hexadecimal, and then C0. Now, to put some practical ideas behind this, a lot depends on what you work with. But I've been very much a system administrator, and I work with IP version 4 addresses. For us humans, they are written in dotted decimal format. But computers, of course, see them in a 32-bit binary address format. So we can convert them from decimal strings to binary strings. So let's look at this step by step before we have our demonstration. We can set up a variable. Here I'm calling it IP_decimal. It has to be a string because the string needs to contain dots. And obviously we can have one dot, a decimal place within a number, but we certainly can't have 3. So we've got 192.168.3.99. We can then split them into their octets. There's nothing special about the word octets, but each decimal number should represent 8 binary bits, so they're known as octets. We're keeping them as decimal at the moment, but we're just going to split them. Split is a method that's contained within our string class, so we have it with all string values. And we're going to split on the dot. So we are creating a list called IP octet, and the list items are going to be delineated by the dot. We can create an IP binary list, which is an empty list. We want to create the list first, so we have the append method of our list to be able to add items to it. We're going to now go through each octet in our IP octet list. So remember, the list is going to contain 192, 168, 3, and 99. This is where we do the conversion. So we can go to our IP binary underscore list and append, but we have to convert this to binary. We want to make sure, though, that we do have 8 bits. The first number, 192, is going to be 8 bits, so we don't have to be too worried about that. But we're using our F strings. We're converting the octet string to an integer and formatting it to be 8 bits of binary. So this will be easy when we look at 192 because that was 8 bits anyway. 168 is 8 bits. But when we look at a binary value of 3, it would just be 1, 1. So we want to pad it out with 6 leading zeros. So 0B would be for binary. 08B was to ensuring that we have 8 bits in the number. We can then create a new list. Here we're calling it binary. Now we can see that we took a string and converted it to a list using split. The reverse of that is join. So we go to the string dot. So dot join. And then we go through and read in each item from our IP binary list. We can then go through and print it out, and this is going to be then an dotted decimal format converted through to a dotted binary format. So when we look at the IP binary, it is going to be our 4 octets in full binary format. Now this looks very complex, and I'm not saying it's easy, but it's a very practical thing that we can implement, and we can look at it slowly, step by step, in the demonstration. So if you're happy to join me, let's move out to our demonstration. So come on, let's dive out to our command line, or at least our Jupyter notebooks, and take a look at our number formatting and a little bit more of a deeper dive into binary notation. So here we are at our glorious Jupyter notebooks. We already know that when working with our numbers, they default to a decimal format. So we can just type 192 and it will evaluate as 192 without any additional formatting around the number. But of course, there are other number formats around, and we're going to be investigating them. But first of all, let's take a look at binary. With this, we can use the binary function, and let's convert the 192 decimal integer into binary. When we take a look at this, the output now shows as binary, but the binary number is prefaced by 0B. So that shows that the number formatting that we are using is binary. The number itself is 11000000. So this is a representation of the decimal 192 as a binary. We can actually take that binary formatted number, let's copy and paste it, pasting it into the code window and shift and enter, and we can see then that we are returned our 192 back as a decimal. We have seen then that we have decimal and binary formats, but there are other formats too. We have octal working with base 8, so that is 0 through to 7. And when we look at converting 192 in decimal, it then comes out as 0 and lowercase o, followed by 300. So this is working in base 8, and of course I can take that base 8 number, and because it's got its formatting in front, we can paste it in into the code window, and we get our 192 coming back. But if that's not enough, we have one final formatting option to look at, and that is hexadecimal. Using hex, we actually have 0 through to 15, but we can't represent our 10, 11, 12, 13, 14 and 15 as numbers, so we use letters A through to F. If we look at converting this, when we look at the conversion, it comes out as 0x, and then the number, the numeric value that we're looking at, is C0. We can go through and copy this, paste it into the code window, and of course, because we've got the formatting option there, we can see that it comes back in our default 192. Now, so far, everything has worked and worked well, and of course it does work. However, some number systems require a minimum number of bits, such as when we are working with IP version 4 addresses. If we have a decimal value of 3 and try and convert that to binary, it comes back as 1, 1. A single 2 and a single 1. So this gives me then my decimal value of 3. But if I needed this as a decimal conversion through to a binary IP address, I would need a minimum of 8 binary bits, meaning that I'm going to have to add in 6 leading zeros. Now, we've already seen using our print function that we can format our strings, so our F strings, and we can go through now and try and format our binary number. So we can take the value of 3, followed by the colon and 08B to show that we want to take the decimal 3 and convert it to binary, but with 8 bits. Closing off our brace brackets, closing off our quotes and closing off our parentheses, you can see now instead of just having 1, 1, we've got our leading 6 zeros, so we have our 8 bits. No value has changed, we're now just padding with leading zeros. With this in place now, we have everything that we need to convert a dotted decimal IP version 4 address to a dotted binary IP address, which we're now going to dive right into. We're going to be looking at doing this manually. I'm well aware that there are libraries within Python that will do this for us, but we want to learn how to code in Python, so we're going to create ourselves a variable. We can call this IP_decimal and give it a value of 192.168.3.99. When we look at that, we can see then, of course, that it does just print out as a string 192.168.3.99. So this is the IP address and the IP address that we are going to convert. The advantage that we have now of running in our Jupyter notebook, rather than just looking at our slides, is that we're able to investigate each variable as we create it. We're going to create a new variable now, IP_octet. There's no special meaning of the name octet, it just means that we are going to be working with 8 bits. This is going to be populated by moving to our string IP decimal and making use of the method split. Split will then split on the dot. So this is going to create 4 elements and store them in the list IP octet. Again, let's go through now and investigate what we have in our IP octet variable, and you can see that it is a list, and it's got the separate values now, 192, 168, 3, and 99. Having them as separate values is going to allow me to convert them separately to the required binary values. Don't worry too much about lists, we'll see more on lists later. For the moment, we're going to create ourselves another variable, and this variable will be an empty list. We're creating an empty list so that we may go through and use the method from this list. So this is the IP_binary list. The square brackets indicate that it's an empty list. We now iterate through our IP octet list for octet in IP octet. As a looping structure, we need to go into a block of code. The colon indicates that we are now indenting for a code block. So we evaluate everything after the for loop that is indented. So we can go through then and populate our IP binary underscore list, and we can use the append method of the list. So we're adding to our empty list. And we're going to put our format string, and we're going to run through more or less the same as we saw before, but I have to convert the string to an integer. So the first value is going to be 192. We use the int function to convert it to an integer, and it's going to be our current iteration of whatever is in our octet variable at the moment. This is going to iterate through 4 times. The first value is going to be 192. We convert it to an 8-bit binary, and then we're ready to close off our brace brackets, close off our quotes, and close off our parentheses. When we hit the big shift and enter, we will process then the data, and we'll process it 4 times. We don't see that happening, but if we go through now and take a look inside of our IP binary underscore list, we're able to see when I hit shift and enter that we have the 4 separate binary values, all of 8 bits. And the final step now is to create a single string representing the dotted binary IP address. We started off with a string, and that was in our dotted decimal format. We now want to convert that through to our dotted binary format. So just as we use the split method to create our list, we're going to use the join method of a string to create a single string from a list. Using then our IP binary as the variable that we're going to populate, we're going to go to a string, and this string is just the single dot. This is what we want to join on. We go through and use the join method of the string, and in the parentheses, we specify the list that we want to join into a single string. So we open up our parentheses and add in our IP underscore binary underscore list. Make sure that we close off the parentheses of the join method and then execute our code. We've now populated the binary, and using our print function, we're able to go through and display the contents of that variable. And when we take a look at this using shift and enter, we should have our glorious IP address now converted through to a dotted binary format. Working through this yourself, you should get some really good hands-on experience of using Python as well as the number conversions.